Good day. So today we will be talking about the second part of the theorems on circle. So if the first part talks about the relationship of the angle towards its intercepted arc, so today we will be talking about the segment relation. So let us start. First one is theorem number 7, so wherein the figure is involved to this one. Theorem number 7 states that if two chords intersect within the circle, the product of the measures of the segment of one, so the product of the measures of the segment of one will be equal to the product of the measures of the segments of the other. So meaning, in this figure, if we are to apply theorem number 7, so we may state that A times B is equal to C times D. So this will be our formula involving a problem on our theorem number 7. So for example, so given this figure, we have the measurement for these parts of our chords, for the segments of our chords. So for the violet chord, we do have the units, 6 units for the first segment, and the other half will be 4 units. And for the red chord, we do have 8 units on the left side, then X unit for the right side. So how are we to find the measurement of the other segment of the red chord? So we just simply multiply the segments of each chord. So we do have 6 times 4 and 8 times X. So we are just simply going to equate those two. So to make it detailed, so we write 6 times 4 equals 8 times X. Or you may immediately write the product of those two. So just only for the sake of complete solution. So 6 times 4, as we all know, is 24. Is equal to 8 times X. So we do have 8X. So to find the value of X, the next thing here is we apply the division property of quality. So we are to divide both sides by the numerical coefficient of X, which is the number 8. So we divide both sides by the number 8 because it is the number that we need to remove beside X. So upon dividing both sides by 8, so we cancel out 8. So what is left now on the right side of our equation is X. While on the left side, 24 divided by 8, that gives us 3. So therefore, the measurement of our X here, or the other segment from our red chord, is 3 units. So that is how we utilize the idea under theorem number 7 involving the segment relation of two chords intersecting inside our circle. Let's have another example. This one, so same figure, similar figure, wherein there are two chords intersecting inside our circle, given the measurements. So for the red chord, we do have 4 units and X units, while for the yellow chord, we do have 3 units and 10 units. So we just simply multiply the segments of each chords. So we are to multiply 4 times X and also 3 times 10. So for the solution, so we just simply write 4 times X. So we may quantify, or we may again immediately write the answer there. So I just simply want to show a detailed solution is equal to 3 times 10. So we do have 3 times 10. So you may choose any of this to come first. So whether 3 times 10 equals 4 times X or vice versa. Then we further simplify. 4 times X, that gives us 4X. Equals 3 times 10, that gives us 30. So just like what we did on the previous, so we are to use the division property of equality by dividing both sides by 4, since it is the number 4 that we need to remove beside X. So we cancel out 4, therefore we do have now X is equal to 30 divided by 4, the answer is 7.5. Okay, so therefore the measurement of this other segment of our green chord is 7.5 units. Okay, so that's how simple theorem number 7 is all about. Let's have the next theorem. Theorem number 8 is talking about this figure. So as you do see, we do have here our tangent line together with our second line intersecting outside our circle. And what is the relationship between their segments? Theorem number 8 tells that if a tangent segment and a second segment are drawn to a circle from an external point, then the square of the measure of the tangent segment is equal to the product of the second segment and its external portion. So meaning, using these values from our segments, so we may state that a squared is equal to b times b plus c. So how does this work in finding the missing measure of our segment involving our tangent and our second line? So let's have a couple of examples for this one. So here on our figure, given the measurements, so for our tangent line, so the one that intersected our circle in exactly 1 point, so our orange line, and for our second line, it is the green one. So we need to find the measurement of our tangent segment, so which is x. So using the idea under theorem number 8, so first is we square the measurement of our tangent segment. So what we do have here is x. So we are to square x. Then it is said to be equal to our exterior second. So our exterior second, so which is b. So here we do have 4. Then we are to multiply it to the sum of the two second segments present on our second line. So we do have 4 times 5 here. So we do have 4 plus 5 rather, 4 plus 5. So next thing we further simplify. So x squared remain as x squared. While on the other side, we may simplify the terms inside our quantity. So we have 4 plus 5, the answer is 9. Then we further simplify, x squared is equal to, so we multiply 4 to number 9. So 4 times 9, the answer is 36. So we need to remove the exponent of our x by simply extracting the roots of both sides of our equation. So the square root of x squared is simply x, and the square root of 36 is 1 positive and 1 negative. But of course, we are only to use the positive one. So we use positive 6 as the square root of 36. So therefore, the measurement of this tangent segment is 6 units. So that is how we use the idea under theorem number 8, or the segment relations of tangent and second line intersecting outside our circle. Another example. So here, given the measurement, so for our tangent line, the segment has a measurement of 8 units, while for our second line, exterior second have a measurement of 4 units, while for the interior second, so this time it is what is x. So how are we to find the measurement of this? Simple. We keep on following the formula or the idea under theorem number 8. So first thing, we square the unit measurement of our tangent first. So we do have here 8. So we are to square our 8. So we do have 8 square equals our exterior second. So we do have 4. Then be multiplied to the sum of our entire second segment. So 4 plus x or x plus 4. Either of those two, it's still correct. So 4 plus x. So next thing, we further simplify. So we may simplify first our exponential term here. 8 squared means 8 times 8. So that gives us 64. Equals, so for the right side, I require you not to do distributive property yet anymore. So we just simply copy it for the sake of our solving process. Because the next thing that we are to do is to remove these entities that accompanies our x. So first thing is we remove this number 4, this number outside our quantity. So again, by simply using the division property of equality, so we are to divide both sides by 4 since number 4 is the one that we need to remove. Okay, so cancel out 4. So therefore, what will be left now on our right side is 4 plus x. Because so we already cancelled out 4. While on the left side, 64 divided by 4, so that gives us 16. Next thing, so we are to transpose this constant term on the other side of our equation. So our equation now becomes 16 minus 4 is equal to x. Then further simplifying, 16 minus 4, so we know that the answer is 12, that is correct, equals x. So we may now conclude that the degree measure, or rather the unit measure of our interior secant here is 12 units. Another one, for example, to make it sure that you will be able to utilize the idea under theorem number 8. So here, so this time it's our exterior secant segment that is missing. Simple still, we follow our formula. First thing is we square our tangent segment, so which is 8, which is 10 rather. So we do have 10 squared. Then equal to, first is our exterior secant that do have a measurement of x. Then multiply to the sum of our entire second segment, which is x plus 15. So next thing, we further simplify our equation. So for the exponential part, we may multiply 10 or simplify 10 squared. So 10 times 10 is said to be 100. Then equals, so for the other side, on the right side, since we do have 2x, so we don't have any choice, but we need to do the distributive property here. So we do have x times x giving us x squared plus x times 15, so that gives us 15x. So what are we to do next? So the next thing is, since we do have two different degree x, so we don't have any choice but to make this a quadratic trinomial. So we need to transpose this 100 to the other side of our equation, making our equation transform into, so what is left now on the left side is nothing, so we do have 0 here, but on the right side we do have now x squared plus 15x, then positive 100 since it is being transposed on the right side, so it now becomes negative 100. Okay, so how are we to find the value of x here in terms of a quadratic trinomial? So we need to do factoring. Okay, so we factor this trinomial into two factors, of course. So for x squared, we do have x. Then for the constant part, so what we just simply need to do or to think is we think of those two numbers. Once multiplied will be equal to 100. Then once subtracted will be equal to 15 or positive 15. So those numbers are the numbers 20 and 5. 20 times 5 is 100. 20 minus 5 is 15. So these are the numbers that we are to use. So this is positive 20, while this one is negative 5. So to further finalize our process, so we solve for each factors for the value of x. So we equate each factors to 0. So x plus 20 is equal to 0. Then x minus 5 is equal to 0. So the next thing, we transpose positive 20 on the other side of the equation. So therefore, x is equal to negative 20, since 0 minus 20 is negative 20. While for the other side, we transpose negative 5 on the other side of our equation. So we do have here x is equal to, so negative 5 becomes positive 5. So 0 plus 5 is 5. So what we are to use between these two, of course, we are to use the positive value. So we conclude now that the unit measure of our exterior secant here is 5 units. Okay, so hope you understand how to utilize the idea behind theorem number 8, or the segment relation between a tangent and a secant intersecting outside our circle. Let's have the last theorem. Theorem number 9 is all about this figure. Okay, so as you notice, we do have two seconds intersecting outside our circle. And what is the segment relation between this? So theorem number 9 states that if two secant segments are drawn to a circle from an external point, then the product of the measures of one of these segments and its external portion is equal to the product of the measures of the other with its external portion. Okay, so similar with our theorem number 8, but this time it is made up of 2 seconds. So using the statement under theorem number 9, so we may state that A times A plus B is equal to C times C plus D. So let's have our example and let us see how does this works in solving for the unknown involving this figure in segment relation. So here we have this our figure. So 2 seconds intersecting outside our circle. So the segment relation will be, so using our data now, so what is unknown is our interior secant for our blue secant line. So for us to find it out, so as simple as following the formula. So let us use the red measurement or our red secant to be our A and B, while for the blue secant will be our C and D. Or you may choose whatever you prefer to use. So we do have, first is our A. So as for you not to be confused, so our A is outside, so we are to use the outside value as well. So our exterior secant to have a measurement of 5 units. Then B multiplied to the sum of the entire second segment. So we do have here 5 plus 1 equals, so be equated to our C. So C is outside our quantity, so we use the outside value as well. So we do have here 3. Then multiplied to the sum of the entire second segment of our blue secant here. So we do have here 3 plus x. Okay. Then we further simplify. So we do have different ways of simplifying. But we may further simplify this equation to be 5. Then on inside our quantity, 5 plus 1 is 6. Then on the right side, I do suggest that you just simply copy our expression on the right side. Then we further simplify 5 times 6. So we are to multiply 5 to 6. So that gives us 30 is equal to, again, for the right side, plainly copy it for the meantime. Then, so what we are to do next here is we remove again this and these parts of our x, no? The one that accompanies our x. So first we remove this term outside, again, by simply dividing both sides by that number that we need to remove. So we divide both sides by that number. So number 3. So in that case, we will be able to remove this term outside. So our equation now transform into, so 3 will be left. 3 plus x will be left on our right side of our equation, while for the left side, 30 divided by 3 is 10. The next thing, we are to transpose this positive 3 to the left side of our equation. So we do have now 10 minus 3 is equal to positive x or plainly x. Then simplifying 10 minus 3, so that gives us 7 equals x. So therefore, the unit measure of our interior secant for our blue secant line is said to be 7 units. So that is how we use this idea under theorem number 9. Another example. So here, let's have a different case. Okay. So here, we do have the second line to wherein still, it is our interior secant that is missing. So let us consider A and B for the orange measurements and C and D for the green measurement. So first, we do have the outside value. So we do have A, and the measurement for our exterior secant here is 4. Then we multiply to the sum of the entire second segment, which is 4 plus x. Then we are to equate this to our exterior secant of the other second line. So we do have 3. Then B multiplied to the sum of our entire second segment, which is 3 plus 9. So similar with the previous example, but in this case, our x appears on the left side of our equation. But doesn't matter, we just simply keep on simplifying it. So for the left side, so let it be still 4 plus x. But if you want to do distributive property for this one, that is still allowed, not a problem. it won't make any changes for our value of x. For this one, so we may further simplify the terms inside our quantity. So 3 plus 9, the answer is 12. Then copy times 3. Further simplifying the right side, so 3 times 12 is 36. Still on the left side, copy 4 times 4 plus x. So the basic idea in solving is we remove these parts that accompanies our x. So the first thing is we need to remove this term outside on the left side of our equation. So we divide both sides by that number that we want to remove. So divided by 4. So we cancel out 4. So what we do have now on the left side is 4 plus x equals, so 36 divided by 4 is 9. Next thing, we transpose 4 on the other side of our equation. So we do have here x is equal to 9 minus 4. Or you may have negative 4 plus 9. So either way, it will have the same answer. So 9 minus 4, so that gives us 5. So x is equal to 5, meaning that the measurement of our interior second segment here is 5 units. Okay? So let us have now an example to wherein what is missing is our exterior second segment. Let's have this, our last example. Using this data, okay, so as what I said, so let us now see how we are to solve for an exterior second segment. So let me use A and B for the red second and C and D for the blue second segment. Okay, so here we do have x, then B multiplied to the entire second segment, so we do have x plus 4. Then be equated to the right side of our C and D. So first we do have 3. Then be multiplied to the entire second segment. We do have 3 plus 1. Further simplifying, our equation now transformed to. So for the left side, we just simply copy it, x plus 4. While on the right side, we do have 3, then be multiplied to, so 3 plus 1 is 4. And 3 plus 4, 3 times 4 rather. So we are to multiply this. 3 times 4 is 12. So for the left side, we still copy it, x times x plus 4. So in this case, we cannot divide both sides by x. So what we can do is to do distributive property. So we don't have any choice but to use distributive property, making our equation transform into x squared plus 4x. By the way, you may do distributive property even on the first part of our computation. Equal to 12. Since there are two different degrees of our x, so we are to make this quadratic trinomial. So we need to transpose this positive 12 on the left side of our equation. So we do have now here x squared plus 4x minus 12 and equals 0. So just like what we did on our previous example, so since we are dealing with a quadratic trinomial, the next thing that we need to do is to do factoring. So for x squared, we do have x and x. For negative 12, so we just simply think of those two numbers. Once multiplied, be equal to 12. Then once subtracted, be equal to 4. So those numbers are the number 6 and 2. So 6 times 2 is 12. 6 minus 2 is 4. So this is positive and this is negative. Then we solve each. We equate each factor to 0. So x plus 6 is equal to 0. And x minus 2 is equal to 0. So upon solving, we transpose positive 6 to the other side, becoming negative 6. So we do have now x equals negative 6. While on the other one, we transpose negative 2 on the other side. So we have here x equals positive 2. Of course, we are to use the positive value only. So therefore, this is what we are to use. So we may state now that the measurement of this exterior secant is 2 units. Okay, so hope you understand the 3 theorems about circle in terms of segment relation. So thank you for watching. So please like and subscribe.